Have you ever wondered how a simple piece of curved metal can make you look completely upside down? Or how a piece of curved glass can let us see galaxies light years away? Well, it's not magic. It's all about the physics of how curved surfaces bend light. So, let's break it down. You know, it all starts with a question you can probably answer right now in your kitchen. Why does your reflection look so weird in a shiny spoon? I mean, one side makes you look one way, and the other side is totally different. It's a mystery we've all seen, and it holds the key to pretty much everything we're about to talk about. This is that classic funhouse effect, right? And it's exactly what happened to a young girl named Mina at a science center. She got up close to a big curved mirror, and her face was huge. But then her brother, standing just a few feet behind her, was completely upside down. It's pretty wild, but by the end of this, you'll know exactly why that happens. Okay, let's get back to that spoon, because it's so much more than just something you eat with. It's actually a perfect little laboratory for understanding the two basic types of curved mirrors. Seriously, if you have a shiny spoon nearby, go grab it. Look into the inner side, the part that holds the soup. What do you see? An upside-down version of yourself. Now flip it over to the back, the part that bulges out. See that? Your reflection is suddenly upright, but it's smaller, a little bit shrunken. Two sides, two totally different reflections. So, what you just saw with that spoon actually demonstrates the two main types of curved mirrors. Now it's time we give them their official names. These are the culprits behind every funhouse effect and a whole lot more. First up, we have the concave mirror. This is the inner part of the spoon, the bowl. Its reflecting surface is caved in. It curves inwards. An easy way to remember it is that a concave mirror looks like a cave you could walk into. On the other side, well, that's a convex mirror. Its reflecting surface bulges outwards, kind of pushing the reflection out towards you. So yeah, your simple kitchen spoon is both a concave and a convex mirror. So how in the world do these shapes create such different images? It really all comes down to the angle of reflection. Picture parallel rays of light hitting the mirror. A concave mirror curves inward, so it bounces those light rays back inward, gathering them all together to a single point. We call that converging. A convex mirror does the opposite. Since it curves outward, it bounces the rays outward, spreading them apart. We call that diverging. And that one simple difference, converging versus diverging, explains everything. This table right here explains exactly what Mina saw at the Science Center. With a concave mirror, if you're really close, your image is upright and bigger. Think of a makeup mirror, or the one a dentist uses. But as you move away, the image totally flips and becomes inverted. A convex mirror, on the other hand, well, it always gives you an upright but smaller image, no matter how close or far you are. Okay, so this isn't just some fun physics trick. This science is absolutely everywhere. In fact, you probably use it every single day without even giving it a second thought. Let's look at a few examples. Concave mirrors are basically masters of focusing light. The shiny reflector inside a flashlight or a car headlight, that's a concave mirror, designed to take the light from a tiny bulb and shoot it out in a powerful, focused beam. Dentists use them to get that super magnified view of your teeth, and giant telescopes use massive concave mirrors to gather the faint light from stars millions of miles away. I bet you have definitely seen this phrase before. It's printed on the passenger side mirror of almost every car. But why? Why is it there? Why does that specific mirror mess with reality? The reason is simple. That car mirror is a convex mirror. It's designed to make the cars behind you look smaller and further away, but in exchange, it gives you a much, much wider field of view. It helps you see into your blind spot. It's a safety trade-off. It shrinks the world just so it can show you more of it. All right, so far we've only talked about light bouncing off a surface. That's reflection. But what happens when light passes through a curved, transparent object? Well, that's when we move from the world of mirrors to the world of lenses. And what you'll notice right away is that the concepts are incredibly similar. A convex lens, which is thicker in the middle, converges light, just like a concave mirror. And a concave lens, which is thicker at the edges, diverges light, just like a convex mirror. The only real difference is that mirrors reflex light by bouncing it, while lenses refract light by bending it as it passes through. Same goals, just a different method. And hey, if you thought mirrors were common, lenses are on a whole other level. They are the heart and soul of eyeglasses, cameras, magnifying glasses, microscopes, and telescopes. They're the tools we've built to manipulate light and see the world in ways our own eyes just can't. Speaking of seeing, all of this amazing technology, from a simple magnifying glass all the way to the Hubble Space Telescope,
It's all just an extension of the most incredible optical instrument known to exist. And that instrument is the lens inside your own eye. Yep, it's a flexible, powerful convex lens that's constantly changing shape, focusing light from everything you see onto your retina. It's a masterpiece of biological engineering that you are using this very second. So here's the big takeaway. Whether you're looking at your upside-down face in a spoon, a dentist is looking at your teeth, or an astronomer is looking at a galaxy far, far away, none of it is magic. It's all governed by the simple, elegant, and totally predictable physics of how curved surfaces bend light. Think about it. From the curve of a drop of water to the big security mirror in a convenience store, the world is just filled with these amazing optical tools. Now that you know the rules of the game, how concave and convex surfaces reflect and refract light, what are you going to start seeing differently around you?